Hello everyone and welcome back. In the last video, we talked about Firebase. We set up a Firebase instance on the Firebase console, and we also brought in the Firebase library into our React application. In this video, before we actually get involved with writing more code, I just want to take a conceptual break and understand what is happening behind the scenes when we use Firebase, as well as how that actually interfaces with our front-end application. This is valuable because as front-end React developers, or even as full-stack React developers, it's very important for us to understand our piece on the stack when it comes to interacting with data. So let's begin with the concept of CRUD. Now, if you are familiar with backends, if you've done any work with servers or anything even remotely similar, you will know what CRUD stands for. But in case you don't, let's break down what CRUD stands for. So CRUD represents the different ways that we can operate on stored data. This stored data usually lives in a database. And generally speaking, you can only perform 4 actions, which is what CRUD stands for. The C stands for create, so you can create data, of course. The R stands for read. Read just means getting data. You don't want to modify the data, you just want to retrieve the data. So think about our front-end application. If we wanted to fetch some data from a backend, then we're asking to read that data. We're not asking to modify that data, we just want to read the data. Update is updating the data. So if we want to change some of the fields, if we want to change maybe some of the values on a piece of data, then we want to update it. And then of course, delete just means deleting that data. So these are pretty much the 4 instances of which you can do in order to operate on stored data. Let's imagine that we had our web application, Crown Clothing on the left here. On the right, you have your Firebase server, which is hosting your database. What you would do is make a request from Crown Clothing to fetch data. So here we're asking to read for some specific data from Firebase. Maybe this is a user profile. Maybe this is something related to a collection of clothing. Maybe this is even a very specific article of clothing. Maybe it's a receipt. You can imagine that the majority of the data in an application would not live on your front end. The reason for this is because if you think about a front end, you have different users that log in and log out of your front end. So as a result, they have specific data that's unique to them that they want. You can't persist this on the front end. You must have this live in some database. So for us, that's going to be Firebase. So when we want that data, we're going to fetch that data, and in turn, Firebase is then going to send back the requested data. This is going to be the same when you're trying to update some data, you're going to create some data, or you're going to delete some data. You're still going to send from Crown Clothing, your front end, that request to do that to the data to Firebase. Firebase will then perform the action and they'll return something back, either the updated data or the created data, or even a confirmation that the data has been successfully deleted. This is the whole basis. It's very simple. You send a request, you get back a response. This is the interaction between a front end and Firebase. But let's think about some things that make this business case more relevant. Firebase represents our database. Our database is going to store all of our data, whether it be our user data, our collection of clothing data, maybe invoices, maybe people's credit cards, maybe even all of the earnings. There's a lot of things that can live in a database for a company. So this means that a lot of this data is really sensitive, and we don't just want anybody to be able to create that data or read that data, update that data, and definitely not destroy that data. So what this means is that we need safeguards. We need some method in order for us to prevent the majority of people from doing things that we don't want them to. Or we want to make sure that specific pieces of data that are sensitive to somebody, such as a person's credit card information, should only be accessible by, most likely, only that person. So this is where authentication becomes important. So let's take a more direct example. Let's say that I'm using crownclothing.com. What I'm going to do is I'm going to request from Firebase my profile data. Maybe on this profile, it has a list of my orders, like my order history. Maybe it has my credit card information. It might even just have my email, my address, and my phone number, all of which are very sensitive data. As a result, Firebase, before it sends me that data, needs me to confirm that I can access this data. Because Firebase doesn't know. How is it going to know that I should be able to access this data? Chances are, in order to do that, I need to authenticate with Firebase. I need to confirm to them that I am who I say I am. And who I say I am is somebody who's allowed to access this profile data. So to do this, maybe I sign in with an email or password, or in some way, Firebase needs to be able to confirm that I am the person who should be able to access this sensitive data. And once I'm able to do that, then Firebase should give me back my profile data. This is going to be the exact same for another user. Let's say Andre accesses our website and he wants to access his own profile data. He's going to go through the exact same authentication flow. He's going to authenticate with Firebase that he should be the person that should access his own profile data. And once he does, Firebase will return that profile data. But if Andre tries to fetch my profile data, Yihua's profile data, unless he can authenticate as me, Firebase is going to say, hey, you know what? There's an error. You are not authorized to get this data. And this is where authentication becomes extremely important. And Firebase has allowed us to leverage both email and password authentication, but also it allows us to use Google Sign-In. So let's imagine and think about how Google Sign-In works. So here we have our website, we have Firebase, and we also have Google servers. On Google servers, it has a bunch of different users that it knows to be who they are based on the fact that they pretty much own your Gmail account, or at least they're aware that when I, Yihua, am trying to access, let's say, my own Gmail account, yihua@gmail.com, Google knows, oh, I know who that user is. If you've used any web applications in today's era, you'll pretty much see Google Sign-In or Facebook Sign-In, even GitHub Sign-In everywhere. It's very prevalent because they know that you are some user. They've authenticated you as the person that you say you are. And they know that the email is unique. So essentially, because they know that, they can share the fact that they know that you are who you say you are to different applications. So remember, that's really all authentication is that it's able to authenticate that you are who you say you are to an application. Google knows you are who you say you are because you have to sign into your Google account, meaning that your email and password should be something only you know. So if you sign into Google, Google's pretty sure that you're probably a person who should be accessing this account, at least most of the time. So Google then can lend that to other applications because Google has authenticated you. So really that's what Google is doing, is Google is helping you authenticate to other applications so that you don't have to make an account for those applications. So let's walk through a flow. Let's say for our Crown Clothing, I'm trying to access Crown Clothing. What I do is I use Crown Clothing's Google Sign-In. So we're going to implement this feature next, but we're just going to walk through a high-level flow. So I'm going to make a request to Google server saying, hey, I want to sign in for this user, yihua@gmail.com. I'm going to send over my credentials. I'm going to either sign in with my email and my password, or if I'm already signed in, I'm just going to tell Google, hey, I'm trying to sign in. What Google will do is say, oh, are those credentials correct? Yes, I can verify this person, so I'm going to generate an auth token. An auth token is just a unique hashed string. It's a string that's really hard to break apart, but essentially on that token is the confirmation that I am who I say I am, which is yihua@gmail.com. Google will then send that back to Crown Clothing. So now Crown Clothing has this auth token. Then what's going to happen is I'm going to send this auth token to Firebase, meaning the backend or the server that Firebase is representing in order for it to verify whether or not I can access some of the data that I'm trying to access specifically. So yihua@gmail.com. Again, maybe it's my profile data, maybe it's my order history, whatever it is, Firebase needs to confirm that I am who I say I am. But with this auth token, it's not enough because Firebase doesn't know whether or not this auth token is valid. Remember, at this point, Firebase can't trust the source where it got the auth token. Somebody could have just copied it from somewhere and then sent it over. It might just be a random auth token. So Firebase needs to confirm, is this auth token a valid auth token? So what Firebase will do is it is going to directly ask Google, can you verify this auth token? Google takes it and it will check, oh, is this auth token one that I've issued? There, Google will be like, okay, If it's true, it's going to say, I have verified this token. If not, it's just going to send back an error. But let's say it's verified. Oh, this auth token is valid. I did issue this token. Google will then send back a verification token, which confirms that the auth token that we got was indeed a valid one. So now Firebase is like, oh, okay, that auth token that Crown Clothing gave me is indeed valid. Now, because Firebase has authorized this token, it is then now going to create an access token. This access token is going to define what the user should be able to access, the user being specific. So this access tells us what me, yihua@gmail.com, is able to access inside of the database. So then Firebase sends this back to Crown Clothing. And now me as the user with this access token, if I want to make different CRUD requests against Firebase, what I'm going to do is I'm going to send the request alongside the access token. Firebase is then going to verify the access token to determine what different things this access token has access to, meaning what is this access token authorized to do. If it is valid, then it will check the CRUD request and say, oh, okay, you are allowed to do and perform this request. So then what's going to happen is that Firebase is going to generate a CRUD response, meaning that it's like, okay, you want to create this data. If you're authorized to do it, I'm going to send you back the appropriate response. The same is true for read, meaning that I'm going to send you back the data that you want to read, update, or destroy. If those are valid, then I'm going to send back the appropriate response. If it's invalid, meaning that if you do not have access to perform that specific request that you are trying to make, that will also be in turn the appropriate response. And that response gets returned to Crown Clothing. And let's assume that it's valid and it's what we want. Let's say we want to read some data. Then our application will now take this data and in turn build the website with that data. And much of the communication from this point forward with our database is always going to need to access this access token, which is what we need to store on our front end. Because this access token allows us to skip having to verify every single step. This access token represents something to Firebase that we can indeed make requests against in the database. So this is a seemingly complicated flow because there's a lot of diagrams, but I promise you once we start building it, it'll be a lot more clear. Because once we start actually building it and implementing the little pieces on the front end, all of this will click in a more meaningful way. But if you're confused about the flow, just watch it again. Once you watch it a few times, if this is unclear, it definitely becomes a lot more clear because each step logically has to happen if you were to authorize a user. So now that we understand this, let's actually start implementing this inside of our code base.